Welcome everybody, it's Ramchandra from CIVIL-MECH-MATHS Concepts channel, and I have released the 6th lecture on Fluid Mechanics 4 regarding pressure measurements, and I have already released 2 MCQs, and my 5 lectures, you please see them for further understanding. And I have given in this the types of measurements of pressure and units of pressure and types of pressure, including cavitation process, and also gauge pressure, atmospheric pressure definitions. In addition to that, I have given details about the different instruments being used for measuring the pressure. And please go through my lectures, previous lectures also, for better understanding. And this series of lectures will be useful for SSCJE and also RRB JE and RBI JE and also GATE and KPSC AE examination, recently given advertisement, Kerala Public Service Commission, and also for UPSC ESC examination. Best of luck to everybody. Please view, review and comment on my lectures for further improvement. Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS Concepts. I have released 3 lectures on fluid mechanics for SSCJE. These lectures can also be used for RRB JE, and also recently, a day back, RBI JE advertisement has also come out. For that examination also, you can use these lectures. And I have been giving lectures on pressure management and pressure definitions. And the pressure definitions are very important as far as the fluid mechanics is concerned. I am speaking little slow in English so that everybody will be able to follow me and understand me well in the subject. The contents of the subject are more important rather than the accent and speed of the speaking. And I wish best of luck to all of you and request you to spread the message to all of your friends also that RBI has released an advertisement for junior engineers, and also recently Kerala Public Service Commission KPSC has also released advertisement for assistant engineers, so that everybody will get benefited by my lectures irrespective of the place from which they belong, and irrespective of the examination conducting body. Almost all the syllabus is same. Almost all the syllabus in civil, mechanical, engineering is same. It is only the amount of the toughness that will be there in the each examination. Toughness levels may vary. Toughness levels may vary, but not the content of the syllabus. content of the subject. I will try my level best to complete the whole syllabus, even though at a lesser speed. I will try to give the maximum difficult engineering situations or engineering practical questions. Those will be useful for you in your examinations. Now, in the last class, I have given certain definitions on the pressure, variation of pressure with height. Now, we will go to the definitions of saturation pressure and vapor pressure. What it is. For example, a vessel is there. A vessel is there and its water is filled with water, not fully, to some extent. Water is there. It is comprising of both liquid and also vapor. It can be water, it can be any other liquid, any other fluid. There is a portion of the container is filled with liquid, some portion of the container is filled with vapor. When there is a equilibrium existing between vapor and liquid at a given temperature, T is equal to constant at a given temperature. We are not varying the temperature. The pressure exerted by the vapor, the pressure exerted by the vapor is exerting some pressure on the liquid. The pressure exerted by the vapor on the liquid at a given temperature under equilibrium conditions is called as the vapor pressure. That is called as the vapor pressure. This is denoted by PV, vapor pressure. Then, when the liquid is there, full liquid, there is no vapor, full liquid is there. Liquid is trying to change its phase. Phase means, for example, ice is there, it is solid. Water is there, it is liquid. Steam is there, it is vapor, steam vapor. That means H2O, that is symbol of water, H2O exists in three phases. One is solid phase, liquid phase and vapor phase. From solid phase to liquid phase, when it changes from solid phase to liquid phase, it is called as phase change. For phase change, it requires some energy. And from liquid to vapor also, water vapor, there is a phase change. It also requires some amount of energy to be consumed by fluid. And your homework is, here I will give homework. What is the energy required for converting 1 kg of ice to water and convert 1 kg of water to water vapor. This phase change is called as boiling. This phase change is called as melting. From ice to water it is called as melting. From water to vapor it is called as boiling. And for melting also energy is required. For melting also energy required. For boiling also energy is required. Then specific energy, that is energy per kg. Energy is measured in joules. Energy per kg required for melting, for boiling, specific energy required for melting and boiling. You please read the books, find these values and note down in your notebook along with the notes what you are preparing with me. This is also very, very important thing which you are required to know. And for example, water boiled and there will be a stage where equilibrium attains, phase equilibrium attained. When phase equilibrium is attained, the saturated pressure of the liquid, now I have not defined saturation pressure. Now you see, there is a phase change. There is a phase change. Saturation pressure is the pressure at a given temperature. Temperature is always constant. We put temperature as constant. Constant means given temperature. The pressure at a given temperature where the liquid changes, it means liquid changes its phase. Liquid is changing its phase from liquid to vapor. That pressure is called as saturation pressure of the liquid. Saturation pressure of the liquid. What is the vapor pressure? When phase is changed, there will be an equilibrium between both the matters. That is what you call gaseous matter and liquid matter. There will be an equilibrium attained in the container. This is the container. This is the container. Then the saturated vapor pressure of the liquid will be equal to the saturated pressure of the liquid will be equal to the vapor pressure. Saturated pressure of the liquid will be equal to vapor pressure. You just see, I will explain you again. This is the container. I am only drawing the container under equilibrium. This is the container. This is the water or liquid or fluid, whatever you call. This is the liquid fluid, this is the vapor. Both will be under equilibrium when the pressure PV, that is vapor pressure, is equal to Psat of the liquid. Psat, P saturated pressure will be referring to liquid, vapor pressure is referring to vapor. This PV is equal to Psat. Under this condition, it is called as equilibrium condition. Equilibrium condition at the given temperature. I think you have understood these two definitions. These are very much required for further understanding. Next, we will go to the next definitions. What is partial pressure? Partial pressure, for example, a container is there like this. Container is there like this. In this, different types of gases are there. There can be liquid also with different colors. There can be liquid also. Just for the clarity sake, I am showing only gases here. And these are the different gases with different colors. Some are in red, some are in green, some are in. Then, the pressure of a particular gas vapor in a mixture. It is the mixture, gas mixture. There are different, for example, red color gas. I am not naming any gas. We can name or we can put a mixture of many gases. This red gas percentage is only 10% is existing. Red color, and it exerts a pressure of P red. Then P red is equal to partial pressure of gas in red color. Red color only I have given red. That's all. You need not be red color gas should be there. It's only a notation. Represented in red color, we can say. Partial pressure. Partial pressure is different from vapor pressure. Don't get confused with the vapor pressure and partial pressure. Partial pressure is the pressure of the particular gas in a mixture of gases. Now, till now we have defined many types of pressures. One is absolute pressure, another is gauge pressure, another is atmospheric pressure, another is vacuum pressure. Please refer to my lecture number 3, FM3, for that type of pressures. Now today we have defined saturation pressure, vapor pressure, and then our partial pressure. Now, let us see. Sometimes what happens in a pipeline or somewhere, fluid is flowing. fluid is flowing. Suddenly the flowing fluid will develop some type of air packets. You heard no? Air packets. Air packets are some packets of obstruction, we can call. Sometimes the pipeline will not be flowing at full depth. Some variation, some gaps will be existing. These gaps are called as cavitation. Cavitation is nothing but a hole, nothing but a gap. Cavitation. And due to this cavitation, what happens? Flow reduces. Flow reduces. If Q is flowing in a pipeline, Q in, there may not be Q out at the same rate as Q in because of the cavitations. The cavitations occur, these cavitations occur whenever the cavitations are related to the vapor pressure. Now you tell me, when cavitations occur and the performance of the flow is reduced, then those cavitations, how they happen? Because of the vapor pressure. Now, tell me, whether under cavitation process, cavitation process, it's a process, it happens, reduces the performance. This happens when the pressure of the liquid falls below the vapor pressure. When the pressure of the liquid falls below the vapor pressure, cavitation occurs. Please think over why there will be a reduction in the performance due to this cavitation. What is the science behind it? What is the science behind? What is the science behind? Science or physics behind formation of cavitation? This is also one of the important processes that happens in the field, which as a junior engineer you are supposed to know that whenever the liquid pressure falls below the vapor pressure, there will be a cavitation process and there will be a danger for erosion. There will be some amount of whatever I can say, drop in performance, especially in turbines, impeller blades. That means we should never allow cavitation to occur and the liquid pressure should never fall down below the vapor pressure. When the liquid pressure falls down the vapor pressure, what happens? You please see this slide. Under equilibrium conditions, when everything is under equilibrium, no changes are taking place, flow was smooth, everything was smooth, the vapor pressure is equal to the liquid pressure. Vapor pressure is the result of the phase change. When liquid pressure falls below the vapor pressure means there will be a change in the phase, a sudden vaporization. The process of sudden vaporization takes place, change in the phase. A sudden vaporization takes place. That sudden vaporization results in the sudden vaporization because of the drop in the liquid pressure results in cavitation. Drop in the liquid pressure causes a sudden vaporization because the equilibrium is lost. This sudden vaporization causes cavitation like this. This cavitation causes erosion in the pipelines or erosion in the impeller blades of the turbine and resulting in reduction in the performance of the impeller blades in the turbine or reduction in the performance of the whole system, piping system or energy producing system. This is the result of cavitation. Please be very, very careful in understanding these important definitions. One is cavitation, second is partial pressure, third is vapor pressure, another is saturation pressure. And what is phase change, what is melting, what is boiling, please understand it thoroughly. Now, as a homework, I will give you some homework on this. As a homework, I will give you homework. Write down at least 10 liquids or fluids, vapor pressures and saturation liquid pressures at any chosen temperature by you. Chosen temperature by you. Now, we will go to the next topic, that is pressure variation. We have already seen pressure varies with depth. I have already explained you pressure. In my first 3 lectures, I have explained you varying of the pressure with depth. This is the H. This is the P atmosphere at A, and it is PB, it is P atmosphere plus rho GH. And pressure varies as dP by dH is equal to, we have seen, rho G. This is very, very important formula which you have to know. And also P is equal to rho GH delta P rho G delta H. This is also very important formula which you are supposed to know. These two. Now, when there is a pressure change with depth, now you tell me, how do you draw it? I am measuring the depth from top to bottom. You just see, just follow me. This is P atmosphere. This is PA. This is PB. This is H. Let me say, I have defined another point, H1 here. Please try to understand. This is H1. This point I can say it is C. And this height is H2. Now, from this diagram we can say that H is equal to H1 plus H2. What is the pressure at C? PA plus rho G H1. What is the pressure at B? PA plus rho G H1 plus rho G H2. That is equal to PA plus rho G H1 plus H2. What is H1 plus H2? Is H. Therefore, it is PA plus rho GH. Then, how do you draw the graph for it? At the top, it is P atmosphere, and at H1, this point it is PA plus rho GH1, and at this point it will be PA plus rho G H1 plus H2. This you should be able to understand well. This is very, very important. We can even draw here. This is H1. This is C. This is B only. And this is H1. This is H2. Total is H. Then P atmosphere we will draw like this. That is standard. Then this is the vertical line. And from this standard we can say up to C it is rho G H1 plus P atmosphere. This is P atmosphere. Please try to understand. And it goes like this, and it will be rho G H1 plus rho G H2 plus P atmosphere, which is nothing but P atmosphere plus rho GH. That's how we have to represent the pressure variation with respect to depth. For example, P atmosphere is taken as datum. If, as explained in my previous classes, if P atmosphere is equal to datum, that if you treat it as 0, because the datum is everywhere same, then when you apply the difference of pressures, how will the diagram will be? This diagram will be like this. Here it is 0, here it is rho GH1, here it is rho GH1 plus rho GH2. This refers to this point. P atmosphere, I made it as 0. Okay. If P atmosphere is taken as datum, that is equal to 0, then this is the diagram. Now, I want to give you homework. Here, it is because it is very important, I am giving you homework. It is even useful, this concept is useful for soil mechanics also. Please try to understand carefully. Soil mechanics also it is useful. Draw the vertical pressure profile at H1, H2, H3 and H4 if total height H of the fluid is equal to H is equal to H1 plus H2 plus H3 plus H4. Draw this. Draw on your own. Draw the vertical pressure profile. Now, as per famous Pascal's law, pressure is equal in all directions. Now, what is hydraulic jack? It's a mechanical arrangement where pressure is applied on a smaller area to lift the larger weights. These are the larger weights of area 2. This is the smaller area where force is applied, area 1. And F1 normal, this is F2 normal. And what is the pressure here? Pressure P1 is equal to F1 by A1. What is the pressure P2 here? F2 by A2. But P1 is equal to P2. That implies F1 by A1 is equal to F2 by A2, which implies F2 by F1 is equal to A2 by A1. On the basis of this principle, hydraulic jack works and a force applied on a smaller area will be able to lift a bigger weights like cars. We can even say what you call building materials and any trucks which are kept on a flat plate, they can be lifted. This is the principle of hydraulic jack. Now, we understood what is the pressure, what are the uses of the pressure. Now we should be able to measure the pressure. How we can measure? For example, I have shown you, if I take atmospheric pressure as the datum, that is equal to 0. Let me take, for convenience of understanding, not that atmospheric pressure is 0, for convenience of understanding, the pressure profile is it's like this. This is A, this is B, this is the height h. The vertical pressure profile is like this. This is A, this is B. And the pressure profile is like this. Pressure increases with height. P is equal to dP by dH is equal to rho g, where for the given system of fluid properties and for given system of temperature and other environmental conditions, this implies dP by dH is equal to constant. Rho g is a constant. That implies dP is equal to some constant into dH. That implies delta P is directly proportional to delta H. That implies P is directly proportional to H. Please remember this. It's very important. P is directly proportional to H. The pressure exerted by the fluid column is directly proportional to H. If H is more, treating atmospheric pressure as 0, we have drawn the triangle. As H increases, pressure increases. This is equal to P. P is as H is equal to 0 means pressure is equal to atmosphere, which we have thought as it as datum. I don't say it's a 0, it's a datum. With respect to datum, we have drawn the graph, drawn the triangle. Now, using this principle, pressure is directly proportional to height of the water column. Pressure is directly proportional to the height of the water column, irrespective of the shape of the container. Irrespective of the shape of the container. Pressure is directly proportional to H. Please try to understand this. Why I am repeating the sentence again and again? It should be in your minds. Pressure is directly proportional to height of the water column. Next, there are different instruments used for finding the pressure. For atmospheric pressure, for finding the atmospheric pressure, P atmosphere is measured by barometer, an instrument called, depending upon the water column or liquid fluid column, a scientist called Torricelli has measured the atmospheric pressure by using an closed inverted tube like in this experiment. He has taken a container in which mercury is filled up to this height. In this, one inverted one side closed tube is put inside the container containing mercury. Then mercury inside the tube rises to a height h above the level of the mercury in the container within the tube, and he measured it to be 760 mm Hg. That is equal to 0.760 meter Hg. And this 760 mm Hg is the atmospheric pressure. P atmosphere is equal to 760 mm Hg. That is equal to 0.760 meter Hg. This particular arrangement is called as barometer. The atmospheric pressure is measured by a barometer. Now, instead of measuring the atmospheric pressure, for units of pressure, please refer to my lecture number 1, 2 and 3, where I have explained clearly about the units of the pressure. For example, instead of measuring the atmospheric pressure, I want to measure the pressure of a fluid inside a closed container. Inside a closed container. That closed container can be either a circular vessel or it can be a box shaped vessel. For example, if I want to measure the pressure in a circular vessel and pressure here, how to measure it? Atmospheric pressure, okay, with the barometer I will be measuring, or using the experiment of putting that in the fluid, putting the inverted one side closed tube inverted, so that I will measure the height and I will get the height and I will convert it into the pressure units. But inside a vessel, how to do it? Then to inside a vessel, what I will do? I will connect one small tube. I will connect one small tube like this And here also I will connect one small tube like this. You can do the drawing in a better way. And to get the inside pressure, that is P in, this small tube connection is called as, this is, I can say, some liquid in blue color. Colors I am using only for the sake of distinguishing, and liquid I have used of this color. And this is the height h, and here also I'll use green color fluid inside. It is up to this, and then inside I'll use some other color. I have used a fluid, either mercury column or water column I will be using, and this height is h. And this cross section I will call it as, this is 1, and I will call it as, this is 2, and I will call it as, this is 1, I will call this as 2. Now, in this arrangement is called manometer. Manometer tubes. These are manometer tubes. Either I can use water or I can use any fluid, but usually any liquid. Usually we use mercury for measuring. The reason for using the mercury also I have explained in my previous 3 lectures. Because mercury is heavy, whose specific gravity is 13.6 and whose density is 13,600 kg per cubic meter. Hence we use mercury in this. Let us say here I have used mercury. Usually we use mercury, and in examination anything can be asked. Don't take that only mercury will be used. Anything can be used. In mercury manometer, this is atmospheric pressure. From whatever we have concluded in the previous chapters, the pressure is directly proportional to the height of the column. If atmospheric pressure is P atmosphere at point 3, P atmosphere at point 3, then pressure gradually increases with depth. Start from point 3, which is P atmosphere. Then P atmosphere, that is 3, plus you reach up to point 2, that is rho GH. Rho is not known. We are only thinking mercury is used. Rho is not known. G is not known. P atmosphere plus rho GH is equal to P at 2. Do you agree? Do you agree with this? Please try to understand, this is very, very important concept for measuring the pressures. P atmosphere plus rho GH is equal to P2. Because H at P1 and P2 is same, they are at the same level. Pressures at same level, horizontal levels is equal to same. That means P1 is equal to P2. P1 is equal to, this is P1. P1 is equal to P2. Because P1 and P2 both are at the same horizontal level. Because pressure depends only on the height, hence pressure will not change at P1. P1 and P2 are at the same height when compared with the atmosphere. Compare with the atmosphere, we have started from 3. From 3, P1 is also at the same height, P2 is also at the same height. Please try to understand. P1 is also at the same height from atmosphere. This is P1. And P2 is also at the same height from atmosphere. Hence, P1 is equal to P2. H is same. P1 is equal to P2. This is very important. P1 is equal to P2 because height is same. P is directly proportional to H. Now, P1 is nothing but pressure in the container. Because this is where all the product is available. Blue shape, you just see blue color. P is equal to Pn is equal to P1. Please understand this also. That blue color product, whatever is there, liquid, that is up to that level, and this P in has exerted a pressure on this column like this, P1, and the height in the manometer tube is increased to H. Hence, P atmospheric plus rho GH is equal to P2, P2 is equal to P1, P1 is equal to nothing but the internal pressure of the tank, that is equal to Pn absolute you get. Pn absolute. You get the value Pn absolute. Then Pn gauge is equal to Pn absolute minus P atmosphere. You understood? This is how we should get the pressure inside a container. This is a single manometer tube we have used. For example, if we use differential manometer, it's a single manometer is used. There can be differential manometers also, and there can be inclined manometers also. And when we use the differential manometer, we can have inverted manometers, differential manometers, inclined manometers. For example, there can be a container like this, to which a manometer is connected like this. Please forgive me for the way I draw the diagram. Sorry, not this way. A manometer can have multi-fluid. This is one fluid and this is another fluid, and fluid in this will be like this with this color. Manometers, forms of manometers. Differential manometer, this is one. Second can be multi-fluid manometer. And there can be single column manometer. In all the cases, the principle of measurement remains the same. Start from P atmosphere, go up to the point where pressure to be measured. Moving downwards, this is very important. Moving downwards, take with positive sign as pressure increases downwards. This is the principle of measurement for manometers. Now, instead of manometers, we can use other mechanical devices also for measuring the pressure. These instruments directly measure the pressure. That is Bourdon gauge. It measures the gauge pressure. Transducers also gauge pressure, or depending upon how the output from the instrumentation is given, the formula, then this can be atmospheric pressure also. In Bourdon gauge, it looks like this. It's a dial. It's like this. It's a circular dial. Where in the center there will be pressure readings here, and we can say, instead of drawing like this, let us draw like this, and there is another circle like this, and there will be a pressure reading here. There will be a needle will be showing the pressure reading. This is directly gauge pressure is measured. Units newtons per square meter or Pascal or whatever units you give it in the gauge pressure. Bourdon gauge. It's a mechanical gauge being normally used in almost all the mechanical or civil systems. Transducers are electronic gauges. Transducers measure the pressure on the basis of the signals they get from the instrumentation. Equipment, electrical signals, let us say, by using the electrical signals. These transducers can be as I told you, they can be gauge pressure transducers, or absolute pressure transducers. The way you define the calculation system in the instrumentation process, the output will be either in the form of gauge pressure or in the absolute pressure. These are the various instruments being used, and these are the various what you call pressure measurements we have to make. And we will do one question from SSCJE 2024 exam on the pressure measurements. You just see, there is one thing called hoop pressure and also longitudinal. Longitudinal means like this pressure. Hoop means circumferential. Then there is a question in (2024) for SSCJE. Let us see it and how simple it is, how easily you will be able to solve it. You will be surprised. Once you know the concepts on the subject, it will be very easy to solve any question. I request all you people to try to understand, rewind my lectures, see my lectures regularly, repeatedly, so that you will recollect or recoup your concepts, and you will understand better, and you will be able to do maximum possible questions, like maximum possible problems associated with my lectures, and then from that you will be able to easily solve any question that is being given in the SSCJE examination as far as civil engineering is concerned. I will be going slowly, and it because examination we expect in the month of October, November, that is paper 1 and then paper 2. Time is there, sufficient time is there. Please utilize your time and do not take shortcuts. Do not guess the answers in the question paper. Please do it and you will get the answers very easily. Very simple questions are being asked, not much difficult questions are being asked, and whatever I am theory is little bit more than what is required, so that if a twisted question is also given, you will be able to answer it very easily in the examination. Now, let us go for the question. I am just searching for the question. You just give me a minute. I will get you. Calculate the hoop tension. Tension means it is what you call force. Tension and compression are forces. Stresses are pressures. Please differentiate between them. There is a circular tank as per the question, and circular tank is having a diameter of 12.6 meters is equal to diameter of the circular tank, and water height is up to 4 meters, and G is given as specific weight. Instead of G, they have directly given rho G, 10 kilonewtons per cubic meter. Specific weight is given, and let us say it is the point A, it is the point B. Then what will be the delta P at B? That is equal to rho GH. What is rho G? 10 into H is 4. 40 kilonewtons per meter square. This is the pressure. Pressure applied at the bottom. And they have asked us to calculate hoop tension. Calculate hoop tension at the base of the tank. The formula for the hoop tension is, because it is not the what you call normal tension they are asking, hoop tension they are asking. Hoop tension is different. Hoop tension is this. This is hoop tension. Normal tension is this. Normal pressure is this. Hoop pressure is this. Hoop pressure is circumferential. Then hoop tension is or we can even abbreviate it as tension hoop is equal to, we know the P, P is equal to 40. PD by 2. This is the hoop tension formula. From this, we can say what is P? We know the value of P as 40. D is given as 12.6 by 2. You please see how much it will be. 20 into 12.6, that is equal to 252 kilonewtons per meter. We just see how simple it is, how easy it is. If you know how to calculate the pressure at a height, you can calculate the pressure at the bottom of the water tank. Then if you know the formula for hoop pressure or hoop tension, then from that you will be able to calculate the hoop tension or hoop pressure, hoop tension per meter. Then hoop tension per meter is equal to hoop tension per unit meter is equal to 252 kilonewtons. How simple it is. Very simple. Not a big problem. It's a simple problem. You will be able to do. Previously also I have done certain fluid mechanics questions which we were able to do in seconds. This is also we will be able to do in seconds. And when atmospheric pressure is taken as the datum, then we will get the gauge pressure. That is also one of the questions is given. Very simple question. And even hydraulic jack we have discussed. Everything we have discussed. These are all very simple questions being asked. And another question I want just you to think over. The answer is very simple. From this prelims only, whatever I have given definitions only, you will be able to answer it. But however, we will be dealing with it in the coming classes. Another question I want to give you. Question. Let me say, which of the following is not the main criteria for selection of hydraulic pumps? Which of the following is not the main criterion for selection of hydraulic pumps? This is also, you can very easily with whatever knowledge you have got till now, you can use it and you can solve it. Atmospheric pressure. B. Flow requirement. Please listen to my previous lectures. Even on MCQs also I have given some lectures. MCQ1, MCQ2. And also fluid mechanics properties, it is the 4th lecture. Almost 6 lectures I have given. The 6 lectures, you please refer. I will give the hint here. Pressure at inlet, and outlet. Don't get confused by the jargon of words. Now, anywhere, whenever we take pressure, pressure is delta P. Delta P, when we take, the atmospheric pressure is eliminated in that. That doesn't have any relevance. And it is used as a datum. So that atmospheric can be equated to 0. That's what I have told. Here, in this diagram, atmospheric pressure is almost taken as 0. Hence, without seeing the other alternatives, you can just say atmospheric pressure does not have any relevance. Until and unless you go for the design with absolute pressures. And for the same place, you want to design a hydraulic pump or a hydraulic system in the same city of your stay or same place in the same country where atmospheric pressure is same, then that is not going to define your designing. But for example, you just see what is the amount of flow required for you. If you require only 100 liters per second or 100 liters per minute LPM, you don't design 1 lakh liters per minute. Hence, flow measurement is required. And if gauge pressure, the pressure from which hydraulic pump is required to pump the product so that it reaches certain part of the field, agriculture field, certain part it has to pour the water, then that is pressure is required. Viscosity. If viscosity of water is lesser when compared with the viscosity of the thick fluids like bituminous, that means viscosity is a requirement, pressure is a requirement, flow is a requirement, but atmospheric pressure is not a requirement only for the reason is that atmospheric pressure can be a datum. These things will be further more and more clear when we go further into the depth of the subject. Don't think that something is given with a pump in array, this pump problem is belonging to some centrifugal pumps, that is 10th chapter or 11th chapter. No. You can club your common sense, you can club whatever you have got till now knowledge, and you can answer the question. And one specialized knowledge you have acquired for pumps also, that we can corroborate this with that and say that my answer is correct. This is how the questions in the examination to be answered. And in the next class, on this property, whatever subject I have cleared till now, on the pressure and properties, I will make some 10 MCQs and discuss them. Please be prepared. Study all this. Please be prepared and come listen to the next lecture of MCQs, which will be very, very typical as I explained in the previous classes. It will be very typical and you will definitely get benefited out of them. Best of luck to everybody. It's Ramachandra from CIVIL-MECH-MATHS Concepts. Please kindly view repeatedly my lectures, review them, comment on them, and ask me questions. I will answer you, and also subscribe to my channel if you feel my lectures are useful to you. Please remember, in the last couple of days, there are advertisements I have seen in the website. There are what you call in Google. There are advertisements for recruitment of RBI JE and also KPSC assistant engineer posts. Please don't leave any stone unturned. Please don't leave the opportunity. Please apply to them. Listen to my classes and best of luck to everybody. This portion, these classes are meant for SSCJE, RRB JE, KPSC examination, PSC examinations, UPSC examination, GATE examination, and also RBI JE examination. Please take advantage of these free classes and do your level best in the examination for your better future. Best of luck again from Ramchandra from CIVIL-MECH-MATHS Concepts.